All right, so we just have a little bit of this section left. So it's on the intermediate value theorem. Okay, so the intermediate value theorem is super important on the AP test. So it pops up a lot on the AP test. So you need to memorize this. So this would be a good thing for a flashcard. So it says, suppose f is continuous on the closed interval. So underline continuous, that's important. And let n be any number between f of a and f of b, where f of a is not equal to f of b. Then there exists a number number c in a to b such that f of c is equal to n. Okay, so this is a lot to memorize. So let me show you the picture, because the picture I think will make more sense. And I'll show you two pictures. Okay, so basically if I have an interval a to b, and I have f of a is here, and then f of b is up here, so those are the heights. And I pick any number between them. So that's going to be a height of n. As long as f is a continuous function, so continuous, as we talked about last time, we can draw without lifting our pencil. So we don't have any holes, we don't have any vertical asymptotes or anything like that. So if f is a continuous function, I'm going to have to connect that first point to the second point. Okay, and I do it by any kind of curve. So I have whatever my function's curve looks like. But when I do that, it crosses that number that I was trying to find. It crosses any height in between f of a and f of b. And that's going to happen at some c value between a and b. So what we're saying is f of c is equal to n. So c is some number between our x values, n is some number between our y values. Okay. So what do we use this a lot for? We use it a lot for zeros. Okay, so let's say I know that I have a and I have b, and let's say f of a is down here, and f of b is up here. Okay, if one has a negative y value and one has a positive y value and it's a continuous function, then I have to be able to cross the x-axis somewhere. So as I'm drawing it, it crosses right there. So in this case, f of c is equal to 0. Okay, so we use it for zeros a lot. Okay, so these next examples involve zeros. So it says, show that there is a root of the equation on the indicated interval. So you have 3x to the fourth minus 5x squared plus x minus 2 equals 0 on the interval -2 to -1. So in the intermediate value theorem, I was talking about f of a, f of b, blah, blah, blah. Okay, I don't have a function written. I don't at any point say f of x equals. Okay, so when that happens, you always have to write your function. Okay, you can't just magically come up with f of 1, right, or f of -1 or whatever. You have to write what f is. So if you do not do that on your AP test, you will get 0 points for something like this. So you need to say let f of x equal 3x to the fourth minus 5x squared plus x minus 2. You also need to use the first thing in the theorem. You need to say that f is continuous. If you have not stated that f is continuous somewhere, you will miss points. Okay? So since f is a polynomial, f is continuous everywhere. Okay, sometimes they're not polynomials. Maybe you have something that looks like f of x equals 1 over x minus 4, and you see that it's not continuous at 4. Would it still be continuous on the interval -2 to -1? Yeah, it would be. So you can always just say f is continuous on that specified interval that you were given. Okay, so it's continuous everywhere. All right, so we have the endpoints -2 and -1. Those are going to be what we plug into the f function. So we're going to find f of -2, and we're going to find f of -1. So f of -2, we're going to plug in -2. Is anybody beating me on this? So we have 16 minus 20 minus 2 minus 2. So -4. Is that right? That's not 16, 48. Dang it, I caught it. Positive 48 too. So 48 minus 20, so 28 minus 4. So 24. All right, and then -1, so 3 times -1 to the fourth minus 5 times -1 squared plus -1 minus 1, or minus 2. So what do we get? So we have 3 minus 5 minus 1 minus 2, negative 5. Okay, so what we're noticing about these values is that 1 is greater than 0, 1's positive, and 1 is less than 0. Okay, so when it says show that there is a root of the equation, right, that means that we can use the intermediate value theorem. So with a rough sketch, and you don't have to draw a rough sketch on your test. Let me draw this a little bit better. So if you plug in negative 2, you got 24. But if you plugged in negative 1, you got negative 5. Okay, so since it's a continuous function, you have to connect those. So you have to cross the x-axis between negative 2 and negative 1. So we're going to say by the IVT, there exists a 0 on negative 2 to negative 1, period. Okay. You can also simplify. If you ever want to simplify there exists, you can write an upside down E. That means there exists. Okay, it's a little math notation. All right, so number 2. So it says use the IVT to verify that f of x equals x squared minus 7 has a 0 on the interval 2 to 3. Okay, then use the method of bisections. So keep having the interval to find an interval of length 1/8 that contains the 0. All right, so what we're going to do is we're going to plug in. So we have f now. We don't have to define what f is. But we know f is continuous, so we have to write that. It's continuous everywhere, so you just write f is continuous.
You also just write it from 2 to 3.
Yeah, you could just say from 2 to 3, yeah. Mm-hmm. All right, so if I find f of 2 and f of 3, when you plug in 2, you get 2 squared minus 7, so 4 minus 7 is negative 3. When you plug in 3, you get 9 minus 7 is 2. So we do know that we have greater than, or not greater, less than 0 and greater than 0. So we know there has to be a 0 between 2 and 3. Okay, does that make sense? So we know that. Okay, but this problem says go a step further. It says find an interval of length 1/8 that contains the 0. So here's what I'm going to do. I'm going to draw a number line. And my original interval was from 2 to 3. Okay, and I knew when I plugged in 2, I got a negative number. When I plugged in 3, I got a positive number. All right, now we're going to slice it in half. We're going to bisect it. We're going to plug in 2.5. Okay, so you can use your calculator. You could plug in f of x, so you could do y1 equals x squared minus 7, and then use your table, since we're going to find several things. So when you find f of 2.5, you should get negative 0.75. Okay, so that's less than 0. So that's negative. So now where are we between? Between 2.5 and 3, right? What's the length of that interval? 1/2, right? So we want to have it again and then one more time. So I'm going to have it again. So I'm going to put in 2.75. And when I do that, I get f of 2.75 is 0.5625. Okay, so that's positive. So now I'm between 2.5 and 2.75. So now I need to do f of, anybody know? 2.625, right. If you didn't know that, you could always go back to your main screen and you could find the average of the two numbers by adding them together and dividing by 2. So you do 2.5 plus 2.75 divided by 2. All right, so when we do that one, we get negative 0.1094. So where is it between? And that's an interval of 1/8 because we halved it 3 times. All right, so there is a 0 on parentheses 2.625, 2.75. Now I could have used brackets, but I chose parentheses. Why am I allowed to do parentheses? Okay, did we have a 0 at those endpoints? No, we knew it wasn't a 0 there because we actually plugged in those numbers and didn't get 0. Okay, so it's okay to do parentheses on those endpoints. All right. So I ask questions like this a lot on the test, and people kind of freak out and have no idea what I'm asking. Okay, so if you see something like this, you can do it. So it says, is any real number exactly 1 less than its cube? So let's write the equation. Is any x value exactly 1 less than its cube? So x cubed minus 1. So is x ever equal to x cubed minus 1? And I know you could like use your calculator, you could find the 0 and so on. I'm not asking you to do that. I'm asking for you to show that this can happen. Okay? So what I want you to do is I want you to subtract your x over and set it equal to 0. And we're going to do that let statement. So we're going to say let f of x equal x cubed minus x minus 1. So if we can find two values where when I plug in one value, I get a positive number, and when I plug in the other value, I get a negative number, then there has to be a 0. So you could go really big. You could be like, I'm going to plug in 1,000 and negative 1,000, right? You could do that, but if you can come up with a small interval, that's good. So a lot of times, like, I have no idea, so I just try something. So if I try 0, I get negative 1. What happens when you plug in 1? You also get negative 1, right? Does that mean it's always negative 1? No, it's not the function f of x equals negative 1, right? So it's not always going to be negative 1. So let's try 2. If I plug in 2, I get 2 cubed minus 2 minus 1. So 8 minus 3, so 5. Okay, ding, 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 that's it, right? So this one was less than 0, and the other one was greater than 0, so that means I have a 0 between 1 and 2. So we need to state that f is continuous. So since f is continuous, there is a 0 between 1 and 2. Well, let me say on. So on the interval 1 to 2 by the IVT. You don't have to write by the IVT, but I'll say. Make sense? All right, that was the last one, right?